Can you see my screen? All of you can see my screen?
Yes, doctor.
If you see my screen, write yes in the chat. Okay, that's good. Okay, today we'll start on inverse trigonometric functions. Before we start, we need to check the sign function. We need to start about the inverse for trigonometric function. Then we will study the inverse for hyperbolic function. But before going to learn the inverse of trigonometric function, we need to remember that trigonometric functions are periodic functions, which means they are not one-to-one. If we look here for the graph of sine, if I need to define the inverse sine function, if you look for the sine function here, the function here is not one-to-one. The function here is not one-to-one. So we couldn't define the inverse on its domain because the function on its domain is not one-to-one function. Okay, so to define the inverse for this function, we have to restrict the domain. We have to restrict the domain. We have to choose a domain that is one-to-one. That is one-to-one. So this domain that is one-to-one, part of this function that is one-to-one, we cannot choose from 0 until 2 pi because it's still not one-to-one. From 0 until 2 pi, still not one-to-one. The one-to-one part is only from minus pi over 2 to pi over 2. From minus pi over 2 to pi over 2, this part. This is the only part that is one-to-one. From this point to this point. This part is one-to-one part. So I can define the inverse for the sine function because this is the graph of sine function. We cannot define the inverse over its domain. We have to define over one-to-one function. So I have to restrict the domain from minus pi over 2 to pi over 2. At this period or at this interval, the function of sine x is one-to-one function. So we can define the inverse over this area. Okay, how to plot the inverse? We need to reflect this graph around the line y equal to x, because we said that any function and its inverse are symmetrical around the line y equal to x. So if we go and reflect this line around the line y equal to x, we can get this one. We can get this graph. This one. When you reflect this part over the line y equal to x, you can get this part. You can get this part. Previous part like that, the second part is like that. So this is the graph of sine inverse x. We reflect this part or this graph over the line y equal to x. Y equal to x. So here, this is the graph of sine inverse x, or sometimes we call it arc sine x. You can write sine inverse x or arc sine x, same function. If you look for this function, the domain here, the range for the sine will become the domain. Sine x range from minus 1 to 1. So this will be our domain here from minus 1 to 1. Our range here, our domain here will be the range. So the range will be the domain for the inverse. The domain for the main function will be the range of the inverse. So the domain of main function, the restricted domain, is from minus pi over 2 to pi over 2. So this will be the range here, from minus pi over 2 to pi over 2. So the function is not one-to-one. So we have to restrict the domain over this interval from minus pi over 2 to pi over 2. So then f of x is one-to-one function. If you look for the sine inverse, then the range here, which is minus 1 to 1, will become the domain. So x between minus 1 and 1. If you look for the domain here, it will become the range. So the range will be from minus pi over 2 to pi over 2, which is y. Y is between minus pi over 2 to pi over 2 for the function sine inverse in x. So to define the function for sine, we have to restrict the domain. We have to restrict the domain first. Then your domain will be the range. Your range will be the domain. The plot of an inverse, same for f of x, but we reflect it over the line y equal to x. Y equal to x. This is the cos x. Same for cos x. Cosine or cos x is not one-to-one function over its domain. Not if you draw a horizontal line, it will cut the graph more than one. So we have to choose a domain that is one-to-one. You have to choose a domain that is one-to-one, then define the inverse. Then define the inverse. So the only domain that is one-to-one is starting from here, from 0 to pi. This part. So this part, the function is one-to-one from 0 until pi. So at this domain, we will define the inverse. So this domain, 0 to pi, will become our range. So first we have to restrict the domain from 0 to pi until 0 to pi. Then the function become 1-to-1. If you plot this function, this is here I plot it using a table. I choose x, any value from minus 1 to 1. And we get the value of y. We plot this, our plot. This is our plot. Here, if you look, this is the same, this function, but we reflect it over y equal to x. We reflect this one over y equal to x. Okay, now, the domain here from 0 to pi will become our range from 0 to pi. The domain here will become our range from 0 to pi. The range here from minus 1 and 1 will become our domain. From minus 1 and 1 become our domain. So x, this is why here when I draw the table for cos inverse, I choose all the value of x between minus 1 and 1, because this is your domain here. From minus 1 and 1, this is your domain. So you cannot plot you cannot take any values of x that is more than 1 or less than minus 1, because your domain here is minus 1 and 1, because this is the range of the original function. The range of the original function will become the domain of the inverse. Now the domain for this one, the restricted domain from 0 to pi will be your range from 0 to pi. So y is from 0 to pi for cos inverse, x from minus 1 and 1. Similar for tan x, tangent x, tan inverse x. This is the function, this is the graph of the function tan x. This is the original graph for the function tan x that we learned in the first class of chapter 2. So this is tan function. The tan function is periodic function, but the function in its domain is not one-to-one. Function on its domain is not one-to-one function. So to make it one-to-one, you have to restrict the domain. So this is your domain. We take this part only. This one. From minus pi over 2 to pi over 2. So this part is one-to-one. Now you can define the inverse. Just reflect over the line y equal to x. So you have your domain here from minus pi over 2 to pi over 2. The restricted domain will be the range. And the range here, which is all real number, will become your domain. So your domain will be all real number for tan inverse x. the range is restricted here from minus pi over 2 to pi over 2 because your domain here is restricted from minus pi over 2 to pi over 2. And we have, since here we have a vertical dot line at pi over 2 and minus pi over 2, which means that the function is undefined at this point. So the inverse will have a horizontal dot line at minus pi over 2 and at pi over 2. Because tan inverse, we cannot find a value of tan inverse pi over 2 and tan inverse minus pi over 2. Any question until now? Do you have any question? If you have any question, you can write it on the chat. You can write it on the chat. Do you know why we have to restrict the domain for this function? Everything is okay, you can write just okay. So I need to know if you get it or not. Okay, good. Now, same for inverse cot function, inverse cotangent function. This is the function cot x. This is one. This is the function cot x. This one. This one is the function cot x. Function cot x. Now this function on its domain is not one-to-one. This function here is not one-to-one, so we have to restrict the domain also. So the domain will be restricted is from 0 to pi. From 0 to pi. So this is your domain. We will define the inverse over this domain. So the domain here from 0 to pi will be the range from 0 to pi. And the range here, which is all real number, will become your domain. Your domain will become all the real numbers. Domain will be all real number. But the range is only from 0 to pi. Why? Because you restricted the domain of the original function from 0 to pi. By similar way, cosecant x. Cosecant x. This is the function cosec x. This is the plot of the function of cosec x. If you look for the cosec x, the domain and the range, the function is not one-to-one on its domain. The function is not one-to-one in its domain. So I have to choose apart from this domain, the function is one-to-one. So we'll choose from minus pi over 2 to pi over 2, only these two areas. First one, this one, and this one. Like this. If you take the function like this, then the function become one-to-one. So we will restrict the domain from minus pi over 2 to pi over 2. And this will be the range of cot inverse x. This will be the range of cosec inverse x. Okay, what about the domain of cosec inverse x? We will look for the range here. If you look for the range, it is from 1 to infinity and from minus 1 to minus infinity. This is your range. So this is become your domain. So your domain will be from minus 1 to from minus infinity to minus 1 and from 1 to infinity. Why? Because this is the range here. We will restrict the range. This is the range, so it will become our domain. And the restricted domain from minus pi over 2 to pi over 2 will be our range. Will be our range. From minus pi over 2 to pi over 2. So you need For any function, the function, all the trigonometric functions are not one-to-one on their domain. So you have to restrict the domain to make the function is one-to-one. And this is the last one, the last trigonometric function, secant x. So if you look for sec x here, it is not one-to-one on its domain. So you have to choose a bar that is one-to-one. So here we choose this part. We choose this one and this one. Here the function is, at this domain, the function is one-to-one. The function is one-to-one. We can define the inverse over this domain from 0 to pi, from 0 to pi. So the restricted domain here from 0 to pi will be our range from 0 to pi for the inverse. And the range here from 1 to infinity or from minus infinity to minus 1, this one will become our domain, So we need to change the domain and the range. Any question? Before going to so this is, in this table, we summarize the domain and the range for the function. These are the domain and the range of each of sine inverse, cos inverse, tan inverse, cosec inverse, and sec inverse. Here you can find the domain and find the range. If you look for sine inverse, cos inverse, the domain from -1 and 1, because sine is always between -1 and 1. So the range for sine become our domain for sine inverse. Cos inverse always cos between -1 and 1. So the range for cos will be the domain for cos inverse. These are the restricted domain that the original function is one-to-one. For sine from minus pi over 2 to pi over 2. For cos from 0 to pi. For tan inverse, we restricted from minus pi over 2 to pi over 2. For cosec inverse, also same from minus pi over 2 to pi over 2 except 0. From sec inverse from pi over 2 to pi over 2 except 0. Except 0 here because here's the range from minus pi over 2 to minus over 2 except the 0 because 0, the original function is undefined at 0. So we can take 0 outside. And take 0 outside. Because the function at 0 we have actually vertical dot line, but because it is a main axis we cannot make it as a dot. But here the function at 0, at pi, at minus pi are not defined, so we have to exclude 0 from the range. So in this table we summarize the domain and the range for all of these functions. It is very important to know the domain of the range for each of these functions, because we need to be careful when we solve the example, as we will show now when we solve any example. This is the cot inverse x. Here you need to have a look for, you need to be know that sine inverse x not equal to 1 over sine x. Sine inverse x 1 over not equal to 1 sine, because this is a cosec function. Cosec function is not the same as sine inverse function. But if we say sine x all between to the power -1 like this is equal to 1 sine x. So we need to differentiate here between sine inverse x and sine x to the power -1, because this one is equal to 1 sine over sine x, but this one not equal to 1 over sine x. So you need to be careful for this one. Before going for inverse trigonometric identities, first, do you have any questions? Do you have any questions? All of you can hear me, right? So if you don't have any questions, just Right, okay, show me that everything is okay with you. I need to show you something else here. Look here for this one. This is, if we draw the sine over its domain, this is the graph of the sine x. This graph is not one-to-one. If you look, this graph is not one-to-one. If you try to show the inverse over its domain, the graph will be like this. This is not a graph of the function. This is not a graph of the function, because to know if the graph is a graph of a function or not, you have, if you draw any vertical line, it should be cut the graph only once. But this is one, if you draw a vertical line, it cuts the graph many times. So this is not a function. So we cannot, if I try to make the inverse over the domain of sine x, we cannot define a function. We cannot find a function. So we have to choose a domain that is one-to-one. Have to choose a domain that is one-to-one. So here for sine, I will restrict it from minus pi over 2 to pi over 2. So this part only is one-to-one. This part only the function is one-to-one. Now you can see the inverse. So this is the plot of your inverse. Now this is a function. If you draw any vertical line, it will cut the graph only once. So this is a function. So we can define the function over f inverse if the original one should be one-to-one function. One-to-one function. Similar for cosine. Similar for cosine. If you try to, this is the graph of cos x, original graph. If you try to show the inverse same, not a graph of the function. So you have to restrict the domain. So here for cosine, I will restrict only from 0 to pi. From 0 to pi, then this one, this is your plot from 0 to 1. This is the line y equal to x. This is the line y equal to x. So, and this is the graph now become one-to-one. From 0 to pi, the graph of the cosine become one-to-one function. So if I need to show the inverse, when we reflect over the line y equal to x, this is your graph. This one is your graph from 0 to pi. From 0 to pi. Similar also for tan x. Tan x, similar. Tan x is not one-to-one function. To make it one-to-one, this is the graph of tan x. This is not one-to-one. If you try to show the inverse here, become like that. This is not a graph of the function. So if you draw vertical line, it cuts the graph many times. So we have to restrict the domain here. So to restrict the domain, you need to make it from 0 to pi. Sorry, from minus pi over 2 to minus pi over 2. This part, from minus pi over 2 to pi over 2, this part is one-to-one. Now you can show the inverse. If you reflect around the line y equal to x, so this is your inverse function. This is why we have to choose a domain that is the original function one-to-one. And this domain will become your range. This domain will become your range. I show you this because now when I solve a questions, you need to be careful about the domain and the range of inverse. For example, here, we know always that a function and its inverse can cancel each other. For example, sine inverse x should be equal to x. Sine inverse sine y should be equal to y. cos inverse x should be equal to x. Cos inverse cos y should be equal to y. Tan inverse x should be equal to x. But is it always true? The question. Also, tan inverse y should be equal to y. But the question is it always true or not? I mean, this relation, sin inverse x equal x, sin inverse sin y equal y, cos inverse x equal x, cos inverse cos y equal y, tan inverse x equal x. Is it simply like that? Is it always true? The answer is no. Not always sin inverse x to equal to x. First, you need to be sure that the x here should be in the range of the first function. X should be within the range of the sign. So if x within the range of the sign, then yes, this one correct. Sin inverse x equal to x. So this is why we said that x should be from -1 to 1. -1 to 1, this is the range for sin x. Same here. When I said that sin inverse sin y should equal to y, I need to be sure that this y is within the range of sin inverse. The range of sin inverse between minus pi over 2 to pi over 2. So the y should be within this range. If y located from minus pi over 2 to pi over 2, then yes, sin inverse sin y equal to y. Okay. Cos inverse x equal to x. Is it always true? No, it should be. You need to be sure that x within the range of cosine. X within the range of cosine. X should be from -1, and if x not within this range, this relation is not correct. So this is why it is important to know the range and domain for each function, to be careful when you solve the questions. Cos inverse cos y, is it always equal to y? No, it is equal to y if y from 0 to y. From 0 to y, which means that y should be within the range of cos inverse. Y should be within the range of cos inverse. And tan inverse x equal to x, this is correct for all x, because here the range of tan is all real number. The range of tan x is all real number, so this one have no issue. But if you talk about tan inverse tan y, it is not always equal to y. You need to be sure that y within the range of tan inverse. Within the range of tan. So you need to be sure that your result located on the range of the first function. If yes, then this relation is correct. Do you have any question before going to the example? This is also some basic relation that we will prove. Sin inverse x plus cos inverse x always equal to pi over 2. And this one we will prove now in the example. Same, tan inverse x plus cot inverse x is equal to pi over 2. Sec inverse x plus cosec inverse x is equal to pi over 2. This one no need to memorize because we give to you in the exam, but you need to know how to prove. How to prove that sin inverse x plus cos inverse x equal to pi over 2. And we will learn how to prove this one in the next example. Okay, cosec inverse x is equal to sin inverse 1 over x. Sec inverse x is equal to cos inverse 1 over x. Cot inverse x is equal to tan inverse 1 over x. And also with this one we will prove sin inverse minus x is equal to minus sin inverse x, because sin inverse is an odd function. Sec inverse minus x is equal to pi minus sec inverse x. Cos inverse minus x is equal to pi minus cos inverse x, because these are even functions. Any questions? Okay, if you don't have any question, we need to start for the example. First example, we need to evaluate. Sine inverse 0.5. Sine inverse 0.5. Sine inverse. This is equal to what? Sine inverse 0.5. This one equal to what?
0.5.
Sine inverse 0.5 equal to what? If you keep not answering, maybe I will give you quiz today or tomorrow in what we explained just now. So please focus with me and answer. Sine inverse 0.5. Yes, 0.5. Okay. Second one, sine inverse 3. This one equal to what? Sine inverse 3 equal to what? Sine inverse 3 equal to what? For a student, write 3. What about the others? Sine inverse 3 equal to what? Math error. The one who write math error should use calculator, right? Titi Hazwani. Titi Hazwani, you use calculator or you know by yourself? For sure math error, because I told you when you write a 3, the 3 within the range of sign. Not the within the range of sign should be between -1 and 1. So here when I explained to you, I told you this relation not always correct. You need to be sure that your result is within the range. Your result is within the range. So sine inverse x equal x, you need to be sure that x is within the range of sine. Here 3 is not within the range of sine. The range of sine is between -1 and 1. So this is one not equal to 3. This one is undefined. This one is math error. This one is undefined. So all those who, yes, it is a math error. It is a math error. You cannot define this function because 3 is not within the range of sine. So those who write 3 need to be careful. Okay, about the third one, sine inverse sine 45. Sine inverse sine 45. Give me the answer. Sine inverse sine 45. Sine inverse sine 45. 45. Yes, this one is 45 because 45 is within the range of sine inverse. So here you have no problem. Sine 45 is within the range of sine inverse because the range of sine inverse between minus pi over 2 to pi over 2. So should be no problem. Okay, now sine inverse sine 135. Sine inverse sine 135 equal to what? Defined. Sine inverse sine 135. Sine inverse sine 135. Undefined. Okay, it is not undefined. It is not equal to 135. Yes, I agree with you. It is not equal to 135. It should be, but we can't say undefined because we can't find, why here we can't say it is undefined? Because I can't find an equivalent angle to 135. So here sine inverse sine 135 is equal to sine inverse, okay, the sine of 135 equal to square root of 2 over 2, right? I need to find the sine inverse for this value. Square root of 2 over 2. This is a positive value. We have two angles that sine inverse is square root over 2, the root of 2 over 2. We have two angles. One is 135, the other one is in the first quadrant, which is 45. Which is the 45. So I will choose the one that it is within our range. I will choose the one that it is within our range. Again, sine inverse sine 135. Sine 135 is the root of 2 over 2, this value. This value is a positive value. Okay. For sine inverse, the sine is a positive in the first and second quadrant. So we have an angle in the first quadrant, and we have another angle in the second quadrant. So to choose which angle we have to use, we need to look for the range of sine inverse. Sine inverse, okay. Maybe I can explain it here. Now, I need sine inverse for the positive value. I have angle here and angle here because sine is positive in this one and in this one also. So which angle I have to choose? Should I choose 135 in the second quadrant or in the first quadrant? I will choose the one in the first quadrant because sine inverse is defined in the first quadrant and in the last quadrant. Sine inverse is from minus pi over 2 to pi over 2. Sine inverse from minus pi over 2 to pi over 2. So it is from first quadrant and last quadrant. So if I need to choose a value, for sure I will not choose the value in the third quadrant. This one I have to delete. So we cannot say that sine inverse sine 135 is equal to 135. No, it is equal to 45. It is equal to the same angle in the first quadrant. Usually, if you calculate sine inverse for a positive value, take your angle in the first quadrant here. If you calculate sine inverse for a negative value, choose from last quadrant. Same for tan inverse. Tan inverse in the same range, from minus pi over 2 to pi over 2. So you calculate tan inverse in the first quadrant. For the positive value, take your angle from the first quadrant. If you calculate tan inverse for negative value, choose your angle from the last quadrant. Cos inverse from first quadrant and second quadrant because it is from 0 to pi. Cos inverse from first quadrant and second quadrant because cos inverse is from 0 to pi. So if you calculate cos inverse for a positive value, take your angle from the first quadrant. If you calculate cos inverse for a negative value, then you have to take your value from second quadrant. Because cos inverse at the second quadrant is negative. So this is why we cannot say that sine inverse sine 135 is not equal, it is not undefined, it is defined but not equal to 135. Because 135 is not within the range of sine inverse. It is within the range of not within the range of an inverse, so you need to choose the angle that an equivalent angle that within the range of sine inverse. This angle will be from the first quadrant because sine 135 is positive, not negative. If sine, for example, 225, this one negative, then sine inverse should be from the fourth quadrant. If you try to calculate sine inverse sine 225, sine inverse. If we can calculate it here, maybe. If I calculate sine inverse of sine 225, this one not equal to 225 because 225 not within the range of sine inverse. It will be equal to sine inverse minus root over 2 to root over 2. So this is a negative value here. This one is negative value. So your answer should be from the last quadrant, minus 45. Sine inverse for a negative value, choose your angle from the last quadrant. So for sine inverse, tan inverse, we choose always from first quadrant and last quadrant, based it is positive or negative. For cos inverse, choose from the first or second, based it is positive or negative. Is it okay? Do you get it or not? Question? If you have any question, you can open the mic and ask. If it is not clear how I make it minus 45 or why it is equal to 45. If it is okay, just write okay on the chat to be sure that you get the idea. Yes, I can repeat for. Okay, again. Here, sine inverse sine 135. This one will not be equal to 135. Why? Because 135 not within this range. Not from minus pi over 2 to pi over 2. I told you this relation correct if the result within the range of the first function. Now I have problem that 135 not within the range of sine inverse. So I cannot say that sine inverse sine 135 is equal to 135. Okay, how I can calculate this one? First, calculate the inside, sine 135. Sine 135 is, if you calculate it on the calculator, it is the root of 2 over 2. Is equal to this value. So I need to calculate the sine inverse for this value. This value, we get it from here. We calculate sine 135. So it is the root of 2 over 2. I need to calculate sine inverse to the root of 2 over 2. This one here is positive value, not negative. Sine 135 is positive value. So your angle should be from 0 to pi over 2, from the first quadrant. So what is the equivalent angle to 135 in the first quadrant? It will be 45. It will be 45. This is why we said sine inverse to this value is 45, not equal to 135. It is equal to 45. I give you another example, sine inverse sine 225. This one not equal to 225 because 225 not in the first or the last quadrant. It is here. So it is not within your range of sine inverse. So it cannot be equal to 225. How I can calculate this one? So I calculate inside first. Calculate sine 225. Sine 225 is minus root over 2 over 2. This value is negative. This value is negative value, which means sine inverse for this value cannot be from the first quadrant. It should be from the last because sine inverse only defined in these two quadrants. So sine inverse this value will be angle in the last quadrant within the range from minus pi over 2 to pi over 2. So it will be minus the equivalent value in the last quadrant, which is minus 45. Minus 45 degree. So be careful when you solve like these questions, because we need to check if the answer within the range of the function, original function or not. Okay? Similar, if you calculate tan inverse for tan value, you need to be sure that calculate the inside the brackets first. If it is positive, take your angle from the first quadrant. If negative, take your angle from the last quadrant. For sine inverse and tan inverse. For cos inverse, calculate the cosine inside first, and then the result. If the result is positive, take your angle from the first quadrant. If the result is negative, take your angle from the second quadrant, because cos from 0 to pi, not from minus pi over 2 to pi over 2. It is from 0 to pi. From 0 to pi. Cos inverse from 0 to pi. Okay. Any other question? Any other question? Okay. Hopefully everything is okay. We need to calculate arc sec minus 2. Arc sec, same sec inverse. Arc sec or arc cos or arc tan, this is the inverse function. So we need to calculate sec inverse minus 2. Sec inverse like cos, because it is equal, sec is 1 over cos. So sec inverse like cos. Now this one is negative value. This one is negative value. The degree is more than 360 degrees, you have to subtract 360 degrees. For example, if you have 450, make minus 360 degrees, and now then you deal with the new angle. So the angle is should be within from 0 to 360 degrees. If it is more, you need to subtract until you get 360. Less than 360. Okay? Sec inverse minus 2. Sec inverse minus 2. Sec inverse minus 2. Oh, sorry. Now this one minus 2 is negative value. So sec will follow cosine, because sec and cosine, because cosine is 1, sec is 1 over cos. So sec and cos same. So negative value, I have to choose my angle from second quadrant. From second quadrant for cos. So sec inverse minus 2 is equal to, sec inverse 2 is 60 degree. So sec inverse minus 2, the equivalent in the second quadrant, which is 102. 102, because I have to choose the angle from second quadrant. So it's be 120 degree. 120 degree. Why? Because I calculated in the negative value. You cannot take the value from the third quadrant. Actually, we have an angle. The third quadrant also have sec minus 2. But your cos inverse and sec inverse from 0 to pi. So you have to follow the range for your function. Okay, what about the number 2? Cosec square cosec inverse the root of 2. What is equal cosec inverse the root of 2? Give me the answer. Cosec inverse the root of 2. Cosec inverse the root of 2. This is equal to what? Give me the answer. Cosec inverse the root of 2. Give me the answer. Cosec inverse the root of 2. $45. What about the others? 45 degree. Only one answer we have, 45. What about the others? Can you calculate cosec inverse the root of 2? Cosec inverse the root of 2. How we calculate this one? How we can calculate the cosec inverse root of 2? That equal, your friend said 45. Agree with her or not? Do you agree with her answer or not? Okay, yes, 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 yes. I also agree with you. Cosec inverse square root of 2 is 45. Cosec inverse the root of 2 is 45. If you don't know how to calculate this one, just it is equal to sine inverse 1 over square root of 2. 1 over x. Using this identity. This one. Oh, okay, this one. Yeah. Cosec inverse x is equal to sine inverse 1 over x. Cosec inverse x is equal to sine inverse 1 over x. So cosec inverse the root of 2 is sine inverse 1 over 2, which is equal, this is a positive value. You have to take your angle from the first quadrant. So it is equal to 45 degree. Is equal to 45 degree. Okay, the last one. Sorry, this is number. The last one. The last one, we need to calculate cot inverse minus 1 over the root of 3. Cot inverse minus 1 over the root of 3. This one equal to what? I need to see your answers. I need to see your answers. Okay. Yeah, you mean tan inverse, not tan. Tan inverse, okay. Okay, you can use this identity here. As I did now, just what I did now for sine inverse, I use this one. This one. Cot inverse x is equal to tan inverse 1 over x. So same. Here, this one is equal tan inverse minus square root of 3. Now you calculate tan for a negative value, so it should be from the last quadrant. So minus 60 degree. Yes. Just use the identities. Just use the identities. Just use the identities. Okay. So any question until now? This is how we calculate the values. Be careful about the range and the angle. Where's the angle? Tan inverse for a negative value should be in the angle in the last quadrant within the range from minus pi over 2 to pi over 2 in this range. You cannot choose an angle from, for example, in the second quadrant because tan is negative there, but it is not within the range. Not within the range. And now I need to prove the identity that we used just now. We need to prove the identity. Sine inverse x plus cos inverse x is equal to pi over 2. I need to prove this one. Show that. We need to prove this one. Sine inverse x plus cos inverse x is equal to pi over 2. Pi over 2. Okay, now I need to prove this one. Sine inverse x plus cos inverse x is equal to pi over 2. Equal to pi over 2. To prove this one, I will assume that theta is equal to sine inverse x. Assume that theta is equal to sine inverse x. What we can conclude that theta is equal to sine inverse x. What we mean by theta is equal to sine inverse x. When I told you theta is equal to sine inverse x, what you can understand from this relation? Theta is sine inverse x. What you can understand from this relation? I assume sine inverse x, I make it equal to theta. So I just assume that theta is equal to sine inverse x. But what we can understand from this one, when I say that theta is equal to sine inverse x, this means that sine theta is equal to x. Sine theta is equal to x. This means that when I say theta is equal to sine inverse x, this means that sine theta equal to x. Sine theta equal to x. Now I need to calculate cos inverse x or cos x because I have sine inverse plus cos inverse. So I need to calculate cos x. How I can calculate cos x? Do you have any idea? I have sine theta equal to x. Can we calculate cos theta? Cos theta. Can you calculate this one? If you know that sine theta equal to x, can you calculate cos theta with respect to x or based on x? Or cannot? if we have sine theta equal to x, if I draw a triangle with right angle, this is theta. Sine is the opposite over hypotenuse. So the opposite is x, the hypotenuse is 1. If I consider this one x over 1. So the opposite is x, the hypotenuse is 1. So x over 1. X over 1. Now by using relation that r squared is equal to x squared plus y squared, by using this relation, for any right triangle, hypotenuse is equal to adjacent, hypotenuse square is equal to adjacent square plus opposite square. So from here, you can conclude that y is the square root of r minus x. Square minus x squared. So this one, y is equal to x. X is equal to, because this is the adjacent, so this one will be 1 minus x squared. 1 minus x squared. So we have, if sine theta equal to x, okay, I have sine theta equal to x. So I draw a triangle with right angle. Theta, sine theta is opposite over hypotenuse. So I consider the opposite is x, the hypotenuse is 1. Now I need to find the adjacent, this one. Always in any triangle with right angles, we have that the hypotenuse square is equal to opposite square plus adjacent square. So if I need to calculate the adjacent square here, it will be the root of the square of hypotenuse minus the root minus the square of opposite. So hypotenuse square is 1, opposite square is x squared. So cos theta is equal to what? Adjacent over hypotenuse, which is 1 is the root of 1 minus x squared. The root of 1 minus x squared. One minus x squared. So, okay. No, sorry, I prove, this is the proof of number 2. Sorry, I'm proving for you number 2. I'm proving this one, cos sine inverse x. Okay, so I will come back again to number 1i. This is the proof of number 2, cos sine inverse x. So here I need to prove that cos sine inverse x is the root 1 minus x squared. So if you look here, what I get, theta is the root of 1 minus x squared. So cos sine inverse x, theta is same sine inverse x. So cos theta is sine inverse x. So cos sine inverse x is equal to the root 1 minus x squared. So this is the second identity. This is number 2, sorry. This is here we prove number 2 first. Cos sine inverse. We assume that sine inverse x is equal to theta. Then I need to calculate cos theta. I need to calculate cos theta. So we need to prove that cos theta is the root of 1 minus x squared. So here what I did is, since theta is sine inverse x, so sine theta equal x. Sine theta is equal x. So sine theta equal x, I draw a triangle with right angle. This is theta. Theta is opposite over hypotenuse. Opposite over hypotenuse. X over 1. From the relation that the hypotenuse square is equal to adjacent square plus opposite square, we can show that 1 square is equal x square plus this value square. So the adjacent square here is equal to root of 1 minus x square. Now from the right triangle here, the angle or triangle with right angle, you can calculate cos theta. Cos theta is adjacent over hypotenuse. Adjacent over hypotenuse, which is the root of 1 minus x square over 1. Over 1. This cos theta. Theta is same sine inverse x. So cos sine inverse x is equal to this value. This is number 2. This is the identity number 2. Any question? I will go back now to proof number 1. But any question? If you have any question, if you like to repeat, I can repeat. Just write on the chat. If okay, write okay. If you need to repeat, I will repeat again. Okay. Now I will now I will prove number 1 for you. Okay, for number 1, need to prove that sine inverse x plus cos inverse x equal 2 pi over 2. I will start same. I will assume theta is equal to sine inverse x. What we mean that theta is equal sine inverse x? What we mean by that theta is equal to sine inverse x? We can understand that theta is equal to sine inverse x. Yes, sine, this means that sine theta equal to x. Or x equal to sine theta. X equal to sine theta. Okay. Also, if I draw, okay, if you have a triangle here, this is theta. Okay, this x, this one, this is pi over 2. If you look for this angle is equal to pi over 2 minus theta. This angle is pi over 2. If this angle is pi over 2, this angle is theta. This angle is equal to pi over 2 minus theta, the third angle. Because all the angle should be 180 degree. So if this is 90 degree and this is 1 theta, it should be 90 minus theta. You can get the value of this angle. For example, if theta is 30, this one is 60. This is 20, this one is 70. The plus of these two angles should be pi over 2. Should be pi over 2. So sine theta is x over 1. Sine theta is opposite over hypotenuse. If I need to calculate cos pi over 2 minus theta, it is equal to what? I need to calculate the cos of this value. Cos of pi over 2 minus theta, this angle equal to what? Cos pi over 2 minus theta. From from this triangle, calculate cos pi over 2 minus theta equal to what? X. Because cos is the adjacent over hypotenuse. Cos is the adjacent over hypotenuse. So if you calculate cos pi over 2, cos pi over 2 minus theta, this one will be also equal to x. This one also equal to x. Why? Because the cosine is the adjacent over hypotenuse. Cosine of this angle is the adjacent for this angle over hypotenuse. So the sine for the theta should be equal to cosine pi over 2 minus theta. Pi over 2 minus theta. So cos pi over 2 minus theta is equal to x. This means that cos inverse x is equal to pi over 2 minus theta. If x is equal to cos pi over 2 minus theta, what we can understand from this? We can understand that cos inverse x should be equal to pi over 2 minus theta. Cos inverse x is equal to pi over 2 minus theta. Now I need to calculate sine inverse plus cos inverse. We have sine inverse, which is theta, and cos inverse pi over 2 minus theta. So sine inverse x plus cos inverse x equal to sine inverse x is theta, because here we assume it equal to theta. Sine inverse x is theta. So I will substitute sine inverse x is equal to theta. Plus cos inverse x, here cos inverse x is pi over 2 minus theta. So this is plus pi over 2 minus theta, which is equal to pi over 2. Which is theta will cancel with minus theta, so it should be equal to pi over 2. So this is how we prove the first one. So again, how I can prove the first one? First, I need to prove that sine inverse plus cos inverse is equal to pi over 2. I assume sine inverse x is equal to theta. Then what we can understand that x is equal to sine theta. If you draw a triangle, sine theta here is the opposite over hypotenuse, x over 1. So x is equal to sine theta. Okay, now I need to calculate the cosine of the next angle, not for theta. This angle is equal to pi over 2 minus theta. Why? Because this angle alone is pi over 2. So the next two angle here, the summation for these two angles should be pi over 2. If this one theta, should be this one pi over 2 minus theta. If theta equal to 30 degree, this one will be 60 degree. 90 minus 30 is 60. If this one 20 degree, this one 70. If this one 45 degree, this one is 45 degree. The summation of two angles should be pi over 2. Now we have x is equal to sine theta. So if I need to calculate the cosine for this value, for this angle, cosine for this angle is the adjacent here, which is x over hypotenuse, which is 1. So cos inverse x, cos y over 2 minus theta is equal to x. Okay, what we can understand from this relation, x equal to cos pi over 2 minus theta. This relation means that cos inverse x also equal to pi over 2 minus theta. Now you can make summation of sine inverse x plus cos inverse x. Sine inverse x is theta. Cos inverse x is pi over 2 minus theta. So theta plus pi over 2 minus theta is pi over 2. This is how we prove the first one. And for second one, similar, but here when I didn't calculate the cosine for this angle, I calculate the cosine for the same angle. For the same angle, it is 1 over cos over minus x squared. So the two proofs are similar. Okay, now the last one. We need, before going for last one, any question for the first proof and second proof? Any question? Okay. Now we need to check sine inverse minus x and minus is equal to minus. We need to prove this one. We need to show that sine, before going to show that this one, by similar way, you can prove this one, tan inverse. We proved this one just now, sine inverse x plus cos inverse x is pi over 2. Exactly same, you can prove tan inverse x plus cot inverse x. So please, all of you, try at home to do this one. Try to prove that tan inverse x plus cot inverse x is equal to pi over 2, because exactly similar to this. If you understand this, you can prove this one. Also this one, sec inverse x plus cosec inverse x equal to pi over 2. So try at home, do these both two. Same proof, but instead of sine and cosine, tan and cot. So try at home if you to check if you understand sine inverse plus cos inverse equal to pi. If you understand the proof of this, you can prove tan inverse plus cot inverse is equal to pi over 2. So please, all of you, try at home to prove that tan inverse plus cot inverse is equal to pi over 2. Okay, go now for the third one. Sine inverse minus x is equal to minus sine inverse x. We need to prove that sine sine inverse minus x is equal to minus sine inverse x. Okay, we need to prove this one. I will start from here. Let theta equal to sine inverse minus x. Okay, what you can understand from this one? Theta is equal to sine inverse minus x. What you can understand? What we mean that theta is equal to sine inverse minus x. Yes, Sophia, sine theta is equal to minus x. Sine, this means that sine theta is equal to minus x. Sine theta is equal to minus x. This means that sine theta is equal to minus x. Okay. And this also make that minus sine theta is equal to x. Minus sine theta is equal to x. Minus sine theta is equal to x. Because we multiply both sides by minus. Sine theta is equal to minus. Theta equal to sine inverse x means that sine theta is equal to minus x. Take sine for both sides. Sine theta, sine inverse will cancel each other. So sine theta will equal to minus x. Now minus sine theta, just multiply by minus. Minus sine theta is equal to x. So, okay, what you can conclude? Minus sine theta equal to what? Minus sine theta equal to what? Minus sine theta. Minus sine theta equal to what? Say that sine is odd function. What we mean by sine is odd function? Minus sine theta equal to what? Yes, sine minus theta, Farah. Good. This is equal to sine minus theta. Minus sine theta is equal to sine minus theta because sine is odd function. Sine minus theta equal to minus sine theta. So since minus sine theta equal to x, this means that sine minus theta also equal to x. Sine minus theta also equal to x. Sine minus theta equal to x. Why? Because sine is odd function. Minus sine theta is equal to sine minus theta. These two sides are equal. Minus sine theta is equal to sine minus theta. This is correct because we know that sine is odd function. This is one of the identities that we get for trigonometric function. So sine minus theta is equal to x. Okay, now this one. What we can conclude that sine minus theta equal to x. What you can conclude. You can understand from that sine minus theta is equal to x. Sine minus theta is equal to x. What you can understand from this relation. Sine minus theta equal to x. Okay. Can we calculate sine inverse in x from this relation? Sine inverse in x will be equal to what? Since sine minus theta is equal to x. So sine inverse in x will be equal to yes, equal to minus theta. Will be equal to minus because we have sine minus theta. You have here sine minus theta. Sine minus theta equal to x. So if you take sine inverse for both sides, so you get sine inverse x is equal to minus theta. Equal to minus theta. Which means that sine inverse x, theta is sine inverse minus x here. So this means that sine inverse x this means that sine inverse x is equal to minus theta, and theta is equal to sine inverse minus x. This is the value of theta. So just replace theta here by its value. So minus sine inverse minus x. Or simply we can say that sine inverse minus x is equal to minus sine inverse x. Is equal to minus sine inverse x. This is what we need to prove. This is what I need to prove here. Sine inverse minus x is equal to minus sine inverse x. So I take this one and assume it is equal to theta. You can start from here. Also same. In my proof, I started from here. You can start from here, same. So I take sine inverse minus x equal to theta. Prove that sine inverse minus x is equal, this is the relation that I need to prove. So I started from this side. Sine inverse minus x make it equal to theta. Theta is equal to sine inverse minus x means that sine theta is equal to minus x. Or another way, minus sine theta is equal to x if you multiply both sides by minus. But I need this one because I need to use the property of the sine that sine is an odd function. So this minus sine theta means sine minus theta same. So sine minus theta is equal to x. Since minus sine theta equal to x, for sure sine minus theta is equal to x also. because these two are equal from the property of the odd function of sine. Okay, what we can benefit from that sine or understand from sine minus theta is equal to x. This means that sine inverse x is equal to minus theta, which means that sine inverse x is equal to minus sine inverse minus x, because theta is equal to sine inverse minus x. Now multiply both sides by minus, so you get that sine inverse minus x, this one, is equal to minus sine inverse x. Minus sine inverse x is equal to sine inverse minus x. So this is the proof. Any question? Any question in the proof? So if you look, when I prove, I just simply use the trigonometric identities. We use the trigonometric identities. You take sine inverse x, make it equal to theta. Then in the first proof, we choose that sine theta is equal to cos pi over 2 minus theta. This is one of the identities. Sine theta is equal to cos pi over 2 minus theta. This is one of the identities that you can see in the trigonometric identities. We use this one. That sine theta for sure be equal to cos pi over 2 minus theta. For the second proof, we have sine theta is equal to x, so just calculate cos theta by using the trigonometric, by using the triangle here, because we have right angle, so the hypotenuse square is equal to adjacent square plus opposite square. So then you can use the definition of sine of cosine. Cos is the adjacent over hypotenuse, which is the root of 1 minus x squared over 1. And the third one, use the identity that sine minus theta is equal to minus sine theta. We will use this one to prove that sine inverse minus x is equal to minus sine inverse x. So you can try at home. If you have any question before going for the next example. Are you ready for the next example, or are you already tired? Are you ready? Because next will go ready. Okay, so this is the last example we will explain today. Okay, we need to, so tomorrow we can start it from inverse hyperbolic function. We need to prove, because in the exam, usually in chapter 2, we ask you to show that, we give you a relation and ask you to show or to prove this relation. Sometimes we give you to find the value of x. To find the value of x. So this previous question we prove. This example, we need to find the value of x that make this relation true. So here I have this relation and I need to solve to find the value of x. Not to prove this part is equal to this part. Here you need to find the value of x. So in the exam you will given 3 questions. 2 maybe proof and 1 find the value of x, or maybe 2 find the value of x, 1 is the proof. So you need to differentiate when you have to prove, when you have to find the value of x. Okay. Now I have this relation is true. 2 sine x plus sine inverse 2x is equal to pi over 2. And I need to solve it to find the value of x. So to simplify, I will assume a is equal to sine inverse x and b is equal to sine inverse 2x. I will replace sine inverse x a, any symbol, and sine inverse 2x to b. Why now the relation become 2a? The relation become 2a plus, because sine inverse x is equal to a. I will replace sine inverse 2x by b. So 2a plus b is equal to pi over 2. To pi over 2. 2a plus b is equal to pi over 2. We just replace sine inverse x by a, sine inverse 2x by b. So you have 2a plus b is equal to pi over. Okay, what we can understand that a is equal to sine inverse x. This means what? A is equal to sine inverse x. This means what? This means what? A is equal to, so what you can understand from sine A equal to x. Sine A equal to x, yes. Now we have sine A equal to x. Okay, what you can understand that P sine inverse 2x. P is equal to sine inverse 2x. This means what? Sine B is equal to 2x. Yes, good. Sine B is equal to x. So we have sine A equal to x, sine 2B equal, and we have this relation also. This relation. A plus P is equal to pi over 2. Sine A is x, sine B is 2x. Okay, what we can do next? What we can do next? What we can do next? What we can benefit from this one? B is equal, okay, yes, B is equal, so sine B is equal, okay. Your friend said that sine, because sine A is equal to x, sine B is equal to x. Yes, correct. So this means that sine B is equal to sine A. Then I need to find the value of x. Remember that you need to find the value of x. Yes, okay, this one correct. What next? What we can do next? Okay, because we don't have enough time, I will show you. Now sine B is equal to sine A. If I multiply both sine by cos B, so by cos A, then you have sine B cos A is equal to sine A cos A. Equal to sine A cos A. This is equal to what? To sine A cos A. This one equal this side. Equal to what? Sine 2A. If you go for the identities, this part, sine B cos A, this part is equal to sine 2A. Is equal to sine 2A. So if I can calculate, sine B is equal to x, we know it. Now I need to know the value of cos A and sine 2A. Already know, okay, from here, you already know that sine B is equal to x. But you need to know cos A and sine 2A. First, how I can calculate cos A? I have sine A is equal to x. Can I calculate cos A or not? I have sine A equal to x. Can I calculate cos A? If I can calculate cos A and sine 2A, we can solve this relation. to find x. So my question is, we know sine b is equal to x from here. What about cos a? I have sine a equal to x, but I need cos a. How we can calculate cos a? It's a triangle, yes. With triangle. You have to go for a triangle. This one. A triangle for a. Sine a is equal to x, which means that opposite over hypotenuse x over 1. This is the sine. If you need to calculate the cosine, it is 1 minus x squared. Need to calculate the adjacent. Because you have sine a is equal to x. Sine is mean opposite over hypotenuse, x over 1. So cos a, from here, cos a is equal to the root 1 minus x squared over 1. Over 1. The hypotenuse is 1. Which is the root of 1 minus x squared. Okay, what about sine 2a? How we can calculate sine 2a? I need to calculate sine 2a. How we can calculate this one, sine 2a? Sine 2a. How we can calculate sine 2a? Can, yes. You can go back for 2 sine a cos a. Or, because if you calculate this one, you will again cancel cos a cos a. But this will not give you anything extra. So I will go for using sine b is equal to x. So here, because we have, okay, I can show you here. Here, because sine b is equal to x, and I need, if I use sine, I can go back for 2 sine a cos a, but the problem is you will cancel cos a with cos a again, so no need for all these steps. You will not get the value of x. You will get x is equal to x. This is what you will get, this relation again. But I need to find an equation of x that I can solve and find the value of x. So here I will not go back for this one. I have sine 2a. I need to calculate sine 2a. I will use this relation. Sine b is equal to x. I will draw another triangle for the value of b. The first triangle for a. The second triangle for b. Now sine b is 2x. Sine b is 2x. This value of this angle here should be equal to pi over 2 minus b. Over 2 minus b. If you look for this relation, if you look pi over 2 minus b, this is the equation that we solved from the beginning. This one, 2a plus b is equal to pi over 2. This means that pi over 2 minus b is 2a. I need to know that this angle, this one, should be equal to A. This angle, this one, this angle, this angle is 2A. Why? Because 2A plus B is pi over 2 from the relation given to you here. 2A plus B is pi over 2 from the first relation. This one. So you need to benefit from the relation given to you. Okay. From here, you can calculate sine 2A. From here, you can calculate sine 2A. But before to calculate sine, you have to calculate this one. This one will be equal to 1 square minus 2x square, which is 4x square. The adjacent here is equal to 1 square minus 2x square, which is 4x square. So from this triangle, sine 2A is equal to the root 1 minus 4x square. This is why I didn't go back to use 2 sine A cos A. Because I need to benefit from this relation given to me, that 2A plus B is equal to pi over 2. If you go back here, 2 sine A cos A will not get nothing, because you will cancel cos A with cos A again. You will cancel this value with this value here. And then you will get back until sine B is equal to sine A. So x equal to x, then you will not get any value for x. So I will not go back to calculate sine 2A from 2 sine A cos A. No, I will use this relation. This relation, if I draw, I know sine B. I know sine B. So here sine B is 2x over 1. I know also this angle should be 2A, because 2A plus B, these two values is equal to pi over 2. So if this angle is equal to B, this angle should be equal to A. So you can calculate from this triangle, you can calculate sine 2A. Sine 2A is the adjacent over hypotenuse, which is root of 1 minus 4x squared. Now you can substitute here. Sine B cos A. Sine B is 2x. Sine B is 2x. Cos A is the root, cos A is the root of 1 minus x squared. The root of 1 minus x squared will be equal to sine 2A, which is 1 minus 4x squared. 1 minus 4x squared. Now I have this relation on x. I can solve this equation and find the value of x. Before solving this equation, you can square both parts. We already write it here. We already write it, the solution here. Okay, now I will solve this equation. Because I have roots, I need to square both parts. Cancel the roots. If you square both parts, this will become 4x squared. Here 1 minus x squared equal to 1 minus 4x squared. If you take the square of both sides. So this is your equation. 4x squared 1 minus x squared is equal to 1 minus 4x squared. So we will solve this equation. We have 4x squared minus 4x squared times x squared is minus 4x to the power 4 equal to 1 minus 4x squared. This one. This part. So now 4x squared plus another 4x squared, which is 8x squared, minus 4x to the power 4, this part, minus 1 equal to 0. So this is a quadratic equation. This one is a quadratic equation. Just rearrange, multiply by minus and rearrange. You have 4x to the power 4 minus 8x squared plus 1 equal to 0. And solve by using the quadratic formula and find the value of x. This file I will upload to you today on e-learning with the full solution. Now with plus, we have x squared, we have two values of x. Here we have when the x is positive, we have a value. When the x is negative, we have a value. So this is the value of x, 1.31. Okay, this is the first value of x. Should we accept or reject? These steps only just I solve this equation that I get. I will repeat again for all of you. I need to find the value of x that give or satisfy this relation, this equation. So I take sine inverse x equal to a, sine inverse 2x equal to b. So the equation becomes 2a plus b is equal to pi over 2. This is the equation is satisfied. So we need to find the value of x that make this equation true. What we can benefit that a sine inverse x, this means that sine a equal to x. What we can understand from b is equal to sine inverse to x, this means that sine b is equal to x. Sine a equal to x, sine b to x, this means that sine b is equal to sine a. X, which means 2 sine a. Multiply both sides by cos a, so sine b cos a will be 2 sine a cos a. This identity is equal to sine 2a. Why I need to go for 2a? What the benefit? Why I have to go for 2a? Because we have 2a here. We know that these two angles is equal to pi over 2. So if I draw a triangle for the angle B, the next angle will be 2A. We can calculate sine 2A because we know that sine B is 2x. So cos B is equal, or the adjacent here will be equal to 1 minus 4x squared. So sine 2A will be the opposite for 2A over hypotenuse. So it will be the root of 1 minus 4x squared. Also, cos A can be calculated from the triangle of A. I draw another triangle for A. You know the sine of A, you can know the cos for A. Substitute in the relation, you get equation. You get this equation only in x. Solve this equation, but before we start to solve, you had to cancel the root. So take the square of both parts. So you have 4x squared, 1 minus x squared is equal to 1 minus 4x squared. Now this is just simple calculations. We solve that the first value of x is 1. So my question is, this, because we have two values of x, one positive, one negative. First, I calculate the positive one. Should we accept or reject? Should we accept or reject? Because this one, you have to reject. This one, because x is more than 1. And we have that sine a is equal to x. Sine a is equal to x, which means that your x cannot be greater than 1. X should be a value between minus 1 and 1, because sine is between minus 1 and 1. So the first value we have to reject. We need to avoid the solution. The only solution you get when x is negative. So this is the only x that satisfies the above equation. This is the only x that satisfies the above equation. Clear or not? Any question? Any question? Okay, so okay, today I will, because maybe you don't have enough time to write, so I will upload for you this recording. I will upload for you today in e-learning to go back through the recording again. And also I will give you I will upload this file with the full solution. Okay. So all this will you find on the e-learning by today, inshallah. So tomorrow we can finish chapter 2 by starting on the inverse hyperbolic functions. Inverse hyperbolic function. Okay. Usually in chapter 2 question the exam, if you check the past year test exam, we ask student 2 types of question: prove or show this relation is correct. Second times question, find the value of x. Find the value of x. So you need to study well for your exam. And any question, you need to wait for the tutorial class, because the tutorial class will be on the same day of the exam. Your exam on Monday, at the morning you have a class. This class will be a tutorial class, not a new subject class. So you can ask before by sending me a WhatsApp message. I will reply when I'm available. Okay, now I will stop sharing this one. I will also stop recording.